Hello children and viewers. So today I am going to solve some problems on lens maker formula. Already you know the lens maker formula. So that is 1 by f equal to refract index of the lens by refract index of the surrounding medium minus 1 into 1 by r1 minus 1 by r2. But in r1 and r2 generally lenses has two surfaces. You get confusion. Which surface can be taken as a first surface? So to overcome them, so the r1 is nothing but radius of curvature of surface on light is incidenting. So that surface taken as a first surface and corresponding to that radius can be taken as r1. And now remember, convex lens is also called as converging lens. So the focal length of the convex lens or converging lens is positive. The focal length of the concave lens or concave lens is also called as diverging lens. So concave lens or diverging lens focal length is negative. So how to look at the problem belongs to the which type of lens. So after that, what is the given data in the problem you have to write. So after that, write the formula and apply the sign convention and simplify the formula, then you get the result. So now the first problem is, so find the refract index of glass. Find the refract index of glass which is a symmetrical convergent lens. So we have to find the refract index of a glass. So that is similar to, which is symmetrical to symmetrical convergent lens. Convergent lens is nothing but what? Convex lens. If its focal length is equal to radius of curvature of its surface. So it is a symmetrical convergent lens. Symmetrical convergent lens means, so symmetrical convergent. Convergent means it is a convex. Symmetrical means both the radius and both the radii of curvature of surface will be same. It is a symmetrical convergent lens. So that is nothing but the problem belongs to the convex lens. So symmetrical means both the radius will be the same and nothing but in the problem what is given. So the problem given that r1 equal to r2. Now consider that equal to r. And as well as, so its focal length is equal to radius of curvature. And in the problem what is given, the focal length is equal to radius of curvature. So and it is a convergent lens. Convergent means nothing but the focal length will be positive. Remember. So now, so this is a given data. So what you have to calculate? You have to calculate the refract index. Refract index of the lens. Refract index of the lens you have to calculate. But the refract index of the medium is not given. So in the problem, if the refract index is not given, so you have to assume that the surrounding medium will be air. Problem lo ganka surrounding medium అనేది ఇవ్వకపోతే surrounding medium ని air అనుకోండి. So the air refract index will be the refract index of the medium is nothing but that is the medium is air. That's why the refract index of air is how much? 1. And now what is the formula to calculate the refract index of the lens? The lens maker formula. So what is the lens maker formula? 1 by f equal to refract index of the lens by refract index of the medium minus 1 into 1 by r1 minus 1 by r2. 1 by r2. This is the formula we have to use. So now, so for this problem we have to apply the sign convention. So now consider for that purpose. So now I am taking the lens here. So now imagine this is a convex lens. So now this is the principal axis and this is optic center. So now imagine this is the light incidenting on the surface. And now nothing but the surface taken as the first surface and now this taken as a second. So now by taking the first surface, when you draw the sphere, you get the sphere. So the center of the sphere is called C1. The distance from the optic center to C1 is called as the first radius of curvature. And by taking the second surface, when you draw the sphere, so you get the sphere. So for that sphere, there is a center of curvature. That center of curvature is called the second center of curvature for the second surface. The distance from the optic center to C2 will be called as second radius of curvature. Second radius of curvature. And so in the problem what is given? Focal length is given, radius of curvature is given. And nothing but for known things you have to apply the sign convention, but unknown things don't apply the sign convention. Now, So to measure the R1, what is the R1? The distance from the optic center to C1. So that's why when you measure the radius of curvature, in which first radius of curvature, in which direction you are moving? In the direction of the incident line, because this is the incident line direction. So all the distance are, what is the sign convention? All the distance are measured from the optic center. The distance is measured in the direction of incident light is positive. The distance is measured opposite to the direction of incident light can be taken as what? Negative. Now when we measure R1, you are moving in the incident direction, that is R1 is positive. And after applying sign convention, after applying the sign convention, so now R1 is positive, that is how much? R. Now coming to the R2. So the distance from the optic center to C2 can be called as the R2. But to measure the R2, in which direction you are moving? Opposite to the incident ray. So that's why the R2 is minus R. Now coming to the focal length. So it is a what? It is a convergent lens. Convergent focal length is nothing but what? Positive. So that's F is plus F. Now, so you apply some convention. Then you have to substitute these values in the equation. So then what you get? 1 by F is nothing but positive equal to refractive index of lens is unknown by what is the refractive index of medium? What is that? 1 minus 1 into, so 1 by R1. R1 is nothing but plus R minus 1 by R2. R2 is nothing but minus R. Minus R. So 1 by F is equal to refractive index of lens by 1 is nothing but refractive index of lens minus 1. So 1 by R. So this minus into minus plus. So 1 by R. 1 by R plus 1 by R is nothing but 2 by R. So 1 by F refractive index equal to refractive index of lens minus 1. 1 by R plus 1 by R is nothing but 2 by R. 2 by R. So but sorry, what is given in the focal length? So F is equal to how much? R. Substitute here. Sorry, I forgot it. So substitute here R also. So then this RR will be cancelled. So here that is nothing but plus R. So this RR will be cancelled. So then what you get? 1 equal to refractive index of the lens minus 1 into 2. Now simplify it. So 1 equal to, what you get? So refractive index, when I bring this 2 to the left side, what happened? 1 by 2 equal to refractive index of the lens minus 1. So again when I bring this minus 1 to the left side, what you get? 1 by 2 plus 1 equal to refractive index of lens. 1 by 2 plus 1 is nothing but how much? 3 by 2. So 3 by 2 equal to refractive index of lens. So what is the refractive index of? Refractive index of lens is nothing but 1.5. Now coming to the second problem. So the second problem is find the radii of a convexo-concave convergent lens. Find the radii of a convexo-concave convergent lens made up of glass with refractive index n equal to 1.5 having focal length 24 cm. So one of the radii of curvature is double the other. The first what you have to identify అంటే మనం ఏం ఐడెంటిఫై చేయాలి అది ఏదే లెన్స్ అది ఏమి లెన్స్ అనేది సో what is the lens given in the problem it is a convexo concave but it acts as a convergent lens it is a convexo concave so convexo concave so this is a convexo concave so this is a lens of convexo concave. So this convexo concave is nothing but finally it can be act as a convergent lens. So convexo concave but it can be act as a convergent lens. So convergent lens is nothing but convex lens. Nothing but its focal length is positive. Focal length is a positive. So this is a convexo concave. Now consider this optic center. This is a principal axis and this is the optic center. So now what is given? The refractive index is how much? 1.5. The refractive index of lens is given, that is how much? 1.5. But the refractive index of surrounding medium is not given. If not given, what you have to assume? The surrounding medium is A. And what is the refractive index of the A? The refractive index of the medium I am taking 1, because why? The surrounding medium is A. And next, focal length is 24. So it is a which type of lens? Convex lens. So that's it, focal length is positive when we are applying the sun convention, remember. So 24 centimeter. And what is given? One of the radii of curvature is double the other. So generally when you observe, the second will be the more and first will be the less. So that's why here the R2 is equal to 2R1 and R2 equal to 2R1, and nothing but one of the radii of curvature is double the other generally. So this will be more and this will be the less, remember. And now in this two one, which one can taken as R1, which can be taken as R2, you have to get confusion. That's why let us consider. So this is the incident light that is incidenting on this surface. Then this is the first surface and this is second surface. And which formula we have? Sir, what we have to find? We have to find the radii, and what is R1 and what is R2. You have to calculate. What is R1 and what is R2? You have to calculate. We calculate cheyali. So now, to find the R1 and R2, which formula we have to take? Lens maker formula. What is that? 1 by f equal to refractive index of lens by refractive index of the medium minus 1 into 1 by R1 minus 1 by R2. But in the problem given that R2 equal to 2R1. So that's why we have to apply the sun convention for focal length R1 and R2. So to apply the sun convention, so now I am taking, this is the incident light, this is incidenting on the surface, that's why the surface is the first surface. So by taking the surface, when I draw the sphere, you get the sphere. So that sphere have some center of curvature, that will be considered C1. The distance from the optic center to C1 can be called as R1. So now to measure this R1, you have to move from optic center to C1, but when you are moving from optic center to C1, in which direction you are moving? In the direction of incident light. That's why R1 can be taken as positive. So after applying sign convention, so this R1 can be taken as R plus R1. Now coming to the R2, by taking the second surface, when I draw the sphere, you get the sphere. So the center of the sphere will be considered C2. The distance from optic center to C2 can be called as R2. Again, to measure the R2, you have to start from optic center and towards the C2. So when you are moving towards the C2, in which direction you are moving? In the direction of incident light. That's why again R2 is positive. R2 is the positive. And again the focal length. The focal length of the convex lens or convergent lens is nothing but positive. So they are equal to plus 24. So then you have to substitute these values in the lens maker formula. So 1 by f. So 1 by f is nothing but plus 24 equal to refractive index of lens is nothing but 1.5 by refractive index of medium is nothing but 1 minus 1 into. So 1 by R1. R1 can be taken as R1. So next minus 1 by R2. R2 is nothing but, so this R1 is also plus R1. And RT is also nothing but how much? RT is nothing but plus 2R1. So 2R1. And next do LCM. So 1 by 24 equal to, so 1.5 by 1 is nothing but 1.5. 1.5 minus 1, 0.5. So next 1 by R1. So R1, 2R1 LCM is 2R1. So with what value the R1 is multiplied to get the 2R1? 2. 2 into numerator value is how much? 1. 2 into 1, 2. Minus with what value the 2R1 is multiplied to get the 2R1? 1. 1 into numerator value is 1. 1 into 1, 1. So that's why 1 by 24 equal to 0.5. 2 minus 1, 1. Got 1 by 2 R1. So next 2 1 the 2, 12 the. So what remains here? So 1 by 12 equal to 0.5 into 1 by R1. Next do the cross multiplication, then what you get? R1 equal to 12 into 0.5. 12 into 0.5 means 12 into 0.5 means 1 by 2. 2 1 the 2 6 the. Nothing but R1 equal to how much? 6 centimeter. So when R1 equal to 6 centimeter, R1 how much you got? 6 centimeter. When R1 is 6, So R2 can be taken as 2R1 and nothing but R2 equal to 2 into 6. Nothing but R2 equal to how much? 12 centimeter. And this radius of curvature is a 12 and for this 6. So this is about the second problem. So third problem. So the third problem is a diverging meniscus lens of 1.5 refractive index has concave surfaces of radii 3 cm and 4 cm. Find the position of the image if an object placed 12 cm in front of the lens. So in the problem, so which type of lens is given? So a diverging meniscus lens. Diverging meniscus lens. So generally in the previous problem I taken that, so this is a convexo concave. This is a convexo concave. This convexo concave is called as what? Convergent lens. Or it may be called as, it can be called as a, so convex meniscus. Convex meniscus. Convex meniscus, or it may be called as, it is a diverging, sorry, it is a converging lens. Convex meniscus is nothing but converging lens. Converging lens. But in this problem, what is given? In this problem, so it is a diverging meniscus. It is a diverging meniscus. Diverging meniscus. So diverging meniscus. So diverging meniscus is nothing but it is a concavo-convex lens. It is a concavo-convex lens. It is a concavo-convex lens. It is a which type of lens? Concavo-convex lens can be act as a diverging meniscus or convex meniscus. So diverging meniscus. So diverging meniscus. So diverging meniscus is nothing but it is a concavo-convex lens. It is a concavo-convex lens. Symbol it may be called as concavo meniscus. Concavo meniscus. Concavo meniscus or diverging meniscus. It is also called as concavo convex lens. So now consider, so this is the principal axis of this lens and this is the optic center. Now you identified the lens, and next what is the data given in the problem? So the diverging meniscus lens of 1.5 refractive index, and nothing but the refractive index of lens is given. So that is 1.5. And but the refractive index of surrounding medium is not given. So when the refractive index of surrounding medium is not given, so consider the surrounding medium is A and the refractive index of the air is nothing but refractive index of medium is how much? 1. And in the problem what is given? So it has concave surfaces. It has a concave surface of radii 3 cm and 4 cm, and R1 is 3 cm and R2 is 4 cm. R1 is the 3 and R2 is the 4 cm. And now find the position of image, and what you have to calculate? Find the position of image, and the V you have to calculate. So if an object is placed 12 cm in front of the lens, and nothing but an object is placed so in front of the lens, at what distance? At 12 cm. Now consider here the object is placed, so it is exactly at how much distance? 12 cm from the optic center, and nothing but what is given? Object distance u equal to 12 cm. So but you have to calculate the image distance. To find the image distance, the focal length is not given. But how can you solve the problem? Already you know that. So what is the lens maker formula? So the lens maker formula is actually 1 by f equal to refractive index of lens by refractive index of the medium minus 1 into 1 by r1 minus 1 by r2. This is only one form. And another form is, so when I am deriving this formula, so first you one formula get. What is that? మొదటగా మీకు ఒక ఫార్ములా వచ్చింది. What is that? 1 by v minus 1 by u equal to refractive index of lens by refractive index of the medium minus 1 into 1 by r1 minus 1 by r2. So in the place of 1 by v and 1 by v minus 1 by u, so we taken this is as 1 by f, and nothing but 1 by f equal to 1 by v minus 1 by u taken. So that's why in the place of 1 by f, what I am taking? 1 by v minus 1 by u. This formula is also called as lens formula, and this is also called as lens maker formula. But we are using here lens maker formula. So what is the lens maker formula I am using here? And another form of lens maker formula, that is 1 by V minus 1 by U equal to refractive index of lens by refractive index of the medium minus 1 into 1 by R1 minus 1 by R2. This is the formula I am taking. But to use this formula we have to apply sign convention. Apply sign convention. So to apply the sign convention, so I am taking, so the incident light is in this direction. So nothing but this is the, this is what? This is the object. From object the light is incidenting on this lens in this direction. Now this surface taken as first surface and this is taken as second surface. So by taking the first surface, when I draw the sphere, so you get the sphere. So the center of curvature for the surface is considered C1. The distance from optic center to C1 can be called as R1. To measure the R1, where you have to start? From optic center and move towards C1. To move towards C1, which direction you are moving? Opposite to incident ray. So that's why the R1 is negative. So R1 is equal minus, but R1 is given how much? Minus 3 centimeter. And next, by taking the second surface, when you draw the sphere, you get the sphere. The center of the sphere is considered C2. The distance from the C2 to optic center will be considered R2. Again, to measure the R2, in which direction you are moving? Opposite to the incident ray. That's why again the R2 is the negative, that is minus 4 centimeter. And so in the problem, what is given? Only this are and nothing but sign. What is given? Object distance. Again, to measure the object distance, in which direction you are moving? So this is the optic center and this is the object. The distance from the optic center to object is called as what? Object distance. To measure the object distance, in which direction you are moving? Opposite direction to incident ray. That's why U equal to minus 12 centimeter. Now substitute these values in the above equation. So 1 by V. So don't apply for unknown things. Sign convention. So 1 by V minus 1 by U. U is nothing but how much? Minus 12 equal to, next refractive index of lens is nothing but 1.5 by refractive index of medium is 1. Next, what is there? Minus 1 into 1 by R1. R1 is there. R1 means minus 3 minus 1 by R2. R2 is nothing but minus 4. 1 by minus 4. Next, simplify. So 1 by V minus into minus plus 1 by 12 equal to 1.5 by 1 is nothing but 1.5 minus 1. Minus 1 is nothing but 0.5. So next to minus 1 by 3 minus into minus plus 1 by 4. Next to do LCM. So 1 by V plus 1 by 12. So 0.5 means 1 by 2. So 3, 4 LCM is the 12. And with what value the 3 is multiplied to get the 12? 4. 4 into minus 1 minus 4. Next plus is there 4. With what value the 4 is multiplied to get the 12? 3. 3 into 1 3. So minus 4 plus 3 is nothing but minus 1. So 1 by V plus 1 by 12 equal to 1 by 2 into minus 4 plus 3 is nothing but minus 1 by 12. So nothing but 1 by V equal to 1 by 2 into minus 1 by 12 is nothing but minus 1 by 24. When this plus 1 by 12 will be taken to the right side, again it will be minus 1 by 12. So 1 by V equal to 24. 12 LCM is the 24. And with what value the 24 is multiplied to get the 24? 1 into minus 1 minus 1. So minus 1 is there. With what value the 12 is multiplied to get the 24? 2. 2 into 1 2. So 1 by V minus 1 minus 2 is nothing but minus 3 by 24. 3 1 ja 3 8 ja. Then what you get? 1 by V equal to minus 1 by 8. Again when I invert it, the తలకిందులు వేసాను అనుకోండి, అప్పుడు ఏమైతుంది? V equal to minus 8 centimeter. And where the image is formed? At 8 centimeter. Now let us consider this is 8 centimeter. Here the image is formed. So why you are getting minus? Nothing but the image is also formed on the same side of the object. Nothing but when you measure the image distance, the distance from the optic center to image, you get the minus. So this is about the third problem. So now coming to the fourth problem. So the fourth problem is the radius of curvature of a plano-convex lens is R. The refractive index, RI means refractive index of material is N. Then then find focal length of lens. So now in the problem, so which type of lens is given? It is a plano-convex lens, and one surface is plane and other surface is the convex. So now it is a plano-convex lens. One is the surface is plane, another one is the convex. So now this is a optic center. Principal axis, this is called the optic center. So this is the optic center. And next, what is given in the problem? The radius of curvature is given. So the radius of curvature of the convex surface is given. So now that is considered. So that is R. And next, the refractive index of metal is n, and nothing but refractive index of lens is n. Then you have to find the focal length. But the refractive index of the surrounding medium is not given, and the surrounding medium is not mentioned in the problem. When the surrounding medium is not mentioned in the problem, we have to take the surrounding medium is air. That's why the refractive index of the surrounding medium become 1 because it is air. So now consider this is the light is incidenting on the surface. So then it becomes the first surface and this is the second surface. And nothing but, so when I take this first surface, now it is a plane. So what is the radius of curvature of the plane surface? Now R1 is the plane surface, that's why R1 become infinity. And now this is the second surface, that's why, so this second surface radius of curvature is given in the problem, and nothing but this become the R2. So now this is the first surface, because why this light is incidenting on the surface, that's why this is the first surface. When I take this first surface, this is the plane surface, that's why what is the radius of curvature of the plane surface? Infinity. So R1 is infinity and R2 is R. Now to find the focal length, which formula we have to use? Lensmaker formula. What is that? 1 by f equal to refractive index of lens by refractive index of surrounding medium minus 1 into, so 1 by R1 minus 1 by R2. So to use this formula, we have to apply sign convention. Apply sign convention. So when I apply the sign convention, so this is infinite, and nothing but when I draw the sphere by taking this plane surface, you have to go to up to infinity. That's why we can't draw for this plane surface. We can't draw the sphere for this plane surface. So that's why R1 become infinity. And now coming to the second. So by taking the second surface, when I draw the sphere, you get the sphere. Now you get the center of the sphere, so that is considered C2. The distance from the optic center to C2 will be called as what? Second radius of curvature, this is R2. Again, to measure the R2, in which direction you are moving? So from optic center to C2. When you are moving from optic center to C2, in which direction you are moving? Opposite to incident ray. So that's why R1 is infinity plus infinity or infinity, and R2 is nothing but what? R2 is nothing but minus. So that is how much? R. So again substitute these values in the above equation. So what you get? 1 by f equal to refractive index of lens is nothing but what? N by 1 minus 1 into, so 1 by R1. R1 is nothing but infinity. Next minus 1 by R2. R2 is nothing but minus R. So this minus into minus become plus 1 by f. N by 1 is nothing but 1. Sorry, n by 1 is nothing but n. N by 1 is nothing but n. N minus 1. So something by infinity is nothing but 0. This minus into minus plus 1 by R. Then again simplify. 1 by f. N minus 1. 0 plus 1 by R. 1 by R. Now when I invert it, f equal to R by n minus 1. So this is the focal length of the given lens. Which type of lens? It is a plano-convex lens. So this is about the problem, and these are the different types of the problems on the Lensmaker form.
Like